Welcome to Embedded Edge, a podcast show hosted by Maurizio Di Paolo Emilio that brings life to some of the stories on embedded systems technologies and products featured on embedded.com and through other AspenCore media publications. In this show, you'll hear both engineers and executives discuss news, challenges and opportunities for embedded systems design in markets such as automotive, industrial, aerospace and consumer. Here is your host, Editor-in-Chief of Power Electronics News and Embedded.com, Maurizio Di Paolo Emilio.
Hello everyone and welcome to another episode of Embedded Edge, where we explore the technologies shaping the future of embedded systems. Today's episode is brought to you by our sponsor, Infineon. In this episode, we speak with Sid Shaw, General Manager for Applications at Infineon's Connected Secure Systems division. Sid leads Infineon's global strategy across key application areas such as smart home, IoT, motor control, and digital health. With smart homes evolving from simple convenience to critical connected ecosystems, the demand for security, efficiency, and intelligence has never been greater. Together, we explore how Infineon is addressing these challenges, what trends are shaping consumer expectations worldwide, and how silicon innovation from MCUs to Edge AI is driving the next wave of smarter, safer, and more sustainable living. Let's talk with Sid. Hi Sid, thanks a lot for being here. How are you?
Hi Maurizio, thank you. Thanks for having me on your show. Doing very well, thanks.
Thank you. Thanks a lot and welcome aboard. Where are you located, Sid?
I am based out of San Jose, California.
Good. So today, in this episode of Embedded Edge, we will talk about smart home and related topics. So before that, I have a couple of questions to share with you. But before that, tell us more about you. Please introduce yourself.
Thanks, Maurizio. Happy to be here. So I'm the Vice President of Marketing and General Management at Infineon's Connected Secure Systems division. Basically, I lead the organization across our key segments inside of Infineon, like smart home, health and fitness, industrial, digital health, while I focus across the entire portfolio of microcontrollers, wireless connectivity, security, sensors, etc. I've been in the industry in IoT for nearly over 2 decades and super excited to chat with you today.
Thank you. So it's a pleasure to have you today talking about smart homes. So let's start. So smart homes have moved from luxury solutions to mainstream adoption. We can see different devices and different applications. So from your perspective at Infineon, so what are the most exciting trends driving smart home adoption today in these days, and how are consumer expectations evolving across different regions?
Yeah, no, thanks, Maurizio. And look, this has come a long way, right? I mean, we've been talking about IoT and smart home for nearly 2 decades, right? A decade and a half at least, and it's come a long way. And I think as consumers, right, us included, across the globe, right, what we see is the pattern is for wanting to interact with devices now very intuitively, right? And new interfaces have emerged, right? So now you have new interfaces like voice, like gesture, like facial recognition, but these are all what we categorize as intuitive, right? So I think that the trend of the consumers and the new consumers, right, is want the interaction to the smart home and to smart devices to intuitively interact with us very seamlessly. So it's not about, you press a button and you get something or you do an action. It just needs to exist and it needs to add value on its own, right? I think many of the homes are moving from like this concept of connected gadgets that we used to have, which were waiting for commands, to now context awareness, where they can react in real time and of course by leveraging AI, right? That said, you still need interoperability, right? And I think that is still a backbone of smart home adoption, right? So interoperability via these unified standards like Matter and things, in the end, they help as a consumer. I don't have to figure out, okay, am I subscribing to this ecosystem or am I subscribing to this brand. I can get any cool device, and I know that if it has a certain standard certification, it's going to work, right? And so I think, and of course, these interoperability things are also making the smart home easier, right? You no longer need to have an engineering degree to install a smart bulb and function it day to day. You should be able to just do it. So I think those are some big trends. There is obviously, and right now I'm talking, everything I talked about is more trends from a consumer behavior perspective, right? There's also trends from regulation, right? And we'll talk about that a bit. But I think there is a very strong focus that we see on energy efficiency and sustainability when it comes to smart home. And this is to obviously keep the electricity bills lower, the consumption lower, and to automatically, right, to do actions, right? The most basic actions we've always talked about, right? Lowering the temperatures, turning off the lights when the homeowners are not there, etc. But you have a lot more advanced use cases where the solar panels are connected to certain things and the batteries and the sprinklers, but context awareness can lead to very significant advantages in savings in energy efficiency and sustainability. And we see this cared about not just by the regulations, but obviously enforced by some regulations, but also cared by the consumer. So I think this is great. And of course, last but not the least, I would say security, right? There's massive, with massive adoption comes possibility in terms of security. And so we see the need for enhanced security and privacy driven by consumers or the need by consumers' concerns and regulations on this.
Okay, thank you, Sid. So we have seen different topics, also different applications like voice recognition, gesture, and you mentioned also energy efficiency, sustainability. This is important. Also, we are talking about smart home. If we have a solar panel, for example, you can control your, you can keep the bills down, as you said. But you mentioned also an important feature, security. So security remains a top concern, especially as the regulations like the EU Cyber Resilience Act reshape the market. So how do you see the balance between regulation, consumer awareness, and technology innovation influencing the future of secure smart home devices?
Yeah, no, absolutely the right question, Maurizio. I mean, let's start with the governments, right? I mean, obviously there is a lot, and very rightfully so, a lot of enforcement of regulations and a lot of creation of this when it comes to cybersecurity and privacy for smart home devices, right? You mentioned the Cyber Resilience Act, CRA in EU, but there's also the Cybersecurity Improvement Act in the US, including the Cyber Trust Mark. There is the PSTI, the Product Security and Telecommunications Infrastructure in the UK. There is cybersecurity law in China now, cybersecurity bill that just passed in Australia. So in summary, right, there's numerous initiatives globally that are happening on this topic. In a lot of those areas, we as Infineon are very much involved because of our legacy in this area and our leadership in this area. But there is a lot of movement. Now, device makers, so the OEMs who are making devices are also designing smart devices to meet these regulations because they want to be able to ship their devices across the world, right? I think if we summarize it from a different angle, right, the future of smart home really depends on aligning innovation with compliance and consumer trust, right? That is the paramount thing, right? You don't want to start getting devices that are hackable and things like that, right? So we think the companies that are going to integrate security by design and communicate it very clearly on what the standards are, they will stand out and differentiate in the market. Right. And then the government regulations that we're talking, this is only going to further enforce it because in some places you won't be able to ship products unless you have certain standards. Right. So this is coming from both sides. The consumer wants it and there's now enforcement of it.
Thank you. So on the technology side, so let's talk about how is Infineon embedding security at the hardware, at the system level with the goal to protect devices, smart home devices from evolving cyber threats. So if we talk about secure elements, trust MCUs, encryption accelerators, so what about?
Great one. So again, for Infineon, we're a leader in embedded security. We've been shipping here now for 2 decades in a variety of markets, from more traditional banking, finance markets to smart cards. And now we're taking this experience over into IoT and addressing the smart home, right? Let's talk first on the basics of security, right? So the base level of security threat involves the malware injection, right? So this is your Mission Impossible legacy of the world, right? Where you're taking a USB stick and you're plugging it in, and basically it's malware injection, right? And this is obviously can be prevented through things like secure boot, root of trust mechanisms that validate the authenticity of firmware that is being executed, right? And of course, malware injection, what they're trying to do is to alter the firmware of the device to gain access to sensitive information, right? And then be able to control it. But that's, I would say, a lot that has been addressed in the last few generations of devices from semiconductors, right? But the emergence of AI, which we know is going to be redefining the way these devices are doing because of all the contextual awareness, this also comes with new security risks, right? Now here you have new ways of so all the way basics like reversing reversing the AI models that are running on this, which are very highly valuable intellectual properties, but not only do they require for IP protection, but if they alter those AI models, it can completely change the behavior of the device, right? To address these risks, it becomes very essential to have secure storage with tamper detection, countermeasures, right? In addition to secure boot, which is now you start looking at a new set of devices. On our side, on the Infineon side, we have a family of devices called the PSOC Edge, but these are designed with security in mind. They can achieve high security levels such as PSA level 4, okay? Now, let's segue in one more thing, and then I come back to you. Let's talk a little bit, as you touched on, post-quantum cryptography, right? The industry is very rapidly moving to secure its microcontrollers against post-quantum cryptography threats, right? And the way we're doing that is by designing lightweight algorithms that have dedicated hardware accelerators with these countermeasures, right? So here, there is no way to do some of these things without hardware, right? You have to make the hardware changes. It's not just a software play. So here again, we have a very strong leadership position in this space with the other family of PSOC, which is called PSOC Control, and specifically the performance line of that, right? This is post-quantum crypto resistant, right? It plans, right? It's implementing PQC security across the entire portfolio, right? Now, in addition to this, there are other security solutions where we have like Optica TPM, the authenticators. These are all designed to provide secure identification, secure authentication, protecting against counterfeits for customers. So in the end, I would summarize by saying, look, we are seeing a massive trend here where leading companies in this spaces are already considering the impact of post-quantum cryptography to avoid these costly retrofits and recalls in the future. And we're seeing the next generation of devices that are coming from all kinds of OEMs. They are starting to say, hey, if I want to future-proof my device, I should start looking at enabling these these security items now so I can be future-proof, because I don't know how stringent the regulation standards will be.
Yeah, thank you. So indeed, the post-quantum cryptography is a hot topic and will be even more in the next year. So thanks for sharing. Let's focus on Edge AI. So the merging of Edge AI, as you said, has introduced new risks and different features. So Edge AI, which is essentially processing data on the device without going to the cloud. So as is a hot topic. So consumers want more features, but they also demand ultra low power consumption. So we don't want to recharge always our devices, and affordable solutions as well. So how is Infineon approaching this trade-off between performance, energy efficiency, cost when enabling the next generation of these smart home devices?
Yeah, thanks, Maurizio. You're addressing a very fundamental engineering problem where we have to continuously try to understand what are the right trade-offs to make, right? But let me start first by saying, look, smart living is the next step in the smart home arena, right?
Yep.
And this is the expectation of the consumer at this point. And there is no smart living without Edge AI, right? If you want IoT devices in the home, Edge AI pretty much enables the smart living, where you don't have to do these point-to-point interactions like we talked about, and things are smart enough to add value and coexist with you, right? Now, with Edge, let's talk about Edge AI then. Edge AI requires real-time processing with higher performance. So the basic definition of Edge AI is it's not going to the cloud for every instance, right? But for that, you're making real-time decisions. You need higher performance. You need better latency. You need no lag time, right? And obviously, still adhere to excellent standards around power consumption. So all of these features that I just talked about can be addressed more efficiently from a cost and power consumption standpoint when an MCU integrates a neural processing unit, right? So an NPU, for instance, right? When you're having that, you actually don't need the traditional microprocessors, NPUs in Edge AI. You can do Edge AI devices because they're also very cost sensitive, right? You can do them with an MCU that has integrated neural processing units to be able to enable Edge AI, and it will do that by both addressing the cost stuff and the power consumption stuff. So I think that's the paradigm shift that we are seeing, and that's where we are very bullish and investing very heavily to drive leadership in that space, right? If you look at over the recent years, Edge AI has made significant progress, right, in optimizing internal power domains, which are very critical for energy consumption in battery-powered devices. And a lot of these Edge AI products will be battery-powered devices, right? Like watches, like bulbs, like things like that, right? Like your security system, your cameras. So the development of optimized lightweight models, these AI models, and dedicated neural processing units, that is what combines to enable devices to run meaningful inferences, right? While still reducing the power consumption. So let me then convert this into a little bit from a product side, right? So if you look at Edge AI and NPUs, like we talked about the PSOC Edge family, right? So this is the U55 running on the PSOC Edge. That's what is allowing for these fast and efficient inferences, resulting in very low power and less heat generation, right? Now, data centers, right? So this is now talking about the cloud, right? They're continuing to get more and more efficient. And then obviously we as Infineon are also very committed to driving efficient data centers use of AI and in lowering the power consumptions and all of that. But here, Edge AI is the other paradigm, right? This has the potential to enable smarter and sustainable experiences at full scale by truly reducing the reliance on power-hungry centers, right? And as a result, you're promoting decarbonization globally, right? So the importance of this, I think, extends beyond battery life. It also contributes to then longer product life cycles, more sustainable environments, and making very critical consideration, and which is in the end tying to everything that we do on the Edge AI solutions, right? Constantly looking at the trade-offs that we need to make.
Thank you. Indeed, talking about Edge AI, we have different features. So and there is a lot of things. So Edge AI, smart homes, is very different from cloud-based intelligence. So can you explain the role of Edge AI in this space and the benefits that brings to voice control, predictive maintenance, cost, and so on?
If we look at some very high-level research data, right, one of the things that we can conclude very easily is a significant percentage of businesses today, right, and let's say 35% or so of the businesses, according to reports, say poor IoT connectivity is the biggest barrier in AI adoption, right, specifically cloud AI, right? And it's because it's not just poor connectivity in remote areas. Still in large estates, and if you have some cameras by the pool and the Wi-Fi is on the other side of the house, it's the latency is too high, right? A large number of these companies are agreeing that once you achieve near 100% global connectivity, then their business cases can thrive. But we're still far from getting there, right? And the basic of this is we know now from all of these companies and these reports that, okay, you need the data needs to be constant, right? There cannot be interruptions in the data for AI to be adopted. So we have a gap today. So data needs to be constant, yet full connectivity everywhere in the world is not there, right? So we know that gap. And the way to address that gap is smart devices to be able to process real-time data with even when there is no connectivity. And this is where Edge AI comes in. It bridges the gap to adoption of AI, and it enables smart devices to process real-time data on the device, which is the edge, without any connectivity, right? The transition, I would say, of AI capabilities from cloud-based infrastructure to edge, that's what enables the smart home devices to become truly intelligent and operate, because they're operating independently without any connectivity, right? This shift is what we were referring to, which will start to introduce context awareness, where the devices will interpret data, they will interpret the user behavior, and they will take the right action at the right time, right? So if we take an example use case, let's say home security requires intelligence, right? Here you have very low latency, which is needed in home security, right? Because if there's a threat, you don't have time to be stuck on going back and forth, right? You need to make decisions very quick, and it's relying on connectivity, right? With Edge AI, the home security, video, audio, motion, vibrations, all of that can be intelligently analyzed simultaneously at the level of the device, at the edge, to make a difference between a family member at the door or an intruder breaking the glass, and all of this with extra, state-of-the-art accuracy, which was not available before, right? And so this reduces the false alarms and all of that, right? So I think this is where we see the market really thriving, right? And of course, edge-based decision-making in those kind of use cases that we talked about results in extremely low latency, but also significantly increased levels of security and privacy, right? So we are expecting a move, and we're seeing that in our consumer, which our customer, which is the OEMs making products. We see this as a massive opportunity, and we see the trend of these companies developing and releasing differentiated products that are differentiated over how much processing they can do on the edge, right? And how much intelligent decisions that can be made from these models on the edge.
Okay, thank you, Sid. So when we talk about edge AI, smart homes, so as you mentioned, we are really talking about running intelligence locally on constrained devices. So in terms of technical point, let's elaborate a bit more in terms of key challenges. So what are such as compute efficiency, you mentioned also energy efficiency, memory. We need also memory to elaborate the data, for example, combining different type of sensor, latency. So how is Infineon addressing them with system solutions?
Yeah, so now we're getting into a little bit more of the technical point of Edge AI. So thanks for that, Maurizio. But I think I would say, look, the foundation of the Edge AI movement is hardware, as we talked about before, right? In addition to the neural processing units like the U55 on the PSOC Edge example, right? That's enabling smart home products to perform AI tasks with reduced power consumption. But in the end, Edge AI is not just that. It relies on the complete solution that includes the hardware enablement, followed by the software, the tools, the AI models, and the security, right? All of this has to come together for then the product manufacturers to be able to fully utilize this and deploy solutions at scale, right? And so here, and missing any of these things, right? Missing the security things, or missing the having imperfect AI models, or having limited hardware capability to be able to run this, then it misses the bigger picture of what the device needs to do. So you need all of that. Now, for here, we, as I said earlier, right, Infineon here is very uniquely positioned, right, on Edge AI market, because we have all of these different pieces, and we've been investing in understanding the system solutions from an application standpoint, bringing all of this together from a use case standpoint, and then delivering to our customers this, right? So this is obviously a necessary component that needs to come together. Now here, in the past, we've talked, and in your podcast as well, right? There's been a lot of talks about sensor fusion. Well, Edge AI brings a very significant boost to sensor fusion because it takes all of this raw data from multiple sensors in real time, but delivers, on the other hand, a very context-aware decision-making, right? So this is almost similar, as you can think, to the human brain, right? You're sensing a lot of different things happening, right? And with the different interfaces that we have in the human body, but then the brain's making a decision. And this is pretty much the simplest way to describe Edge AI here. So here also, of course, the combination of hardware acceleration, algorithm optimization, these things become very critical. And this is where a lot of our engineering focuses.
Thank you. So Infineon looks at application on both global and regional levels. So you mentioned a bit at the start. So could you share some differences you see between the markets, for example, Europe, Asia, United States? So when it comes to adoption of smart home technologies?
Yeah, no, great question. And we're seeing different focus and trends. Of course, in the end, the consumer behaviors of wanting these conveniences and smart living in the smart home will be common across the world, right? And as we're humans. But of course, as you pointed very rightfully, we're seeing different trends in the regions based on not just the consumer behavior, but also the regulation, right? And so to quickly touch on that, right? So if we look at Americas here, right, almost 80% of the household penetration for smart homes in the US, consumers are very much oriented around convenience, very strong demand for DIY setups. If you look at Europe, a lot of focus on privacy, right? Also energy regulation, right? Compliance with that, green energy. So we see this as very much of a driving factor and awareness there. And it plays very well to our strengths here from the things that we talked about, from power consumption and all of that, right? If you look at China, for instance, very, very fast adoption here, driven by, of course, the general appetite of convenience, rapid implementation of AI for personalization. We see a lot of use cases here that are very, very niche to the consumers and the consumer behaviors in China, but are used for AI for personalization across that, right? If you look at the rest of Asia, there's a lot of interest we are seeing in more affordable smart home systems, right? And of course, if you then one of the things that we see a lot in Japan and Korea, for instance, is really a very continuous growing demand for how Edge AI can help in elder care and health related features. So the most common level there is it's convenience, but when you, as you rightfully said, right, if we start to break it down by regional patterns, that's a lot of what we're seeing today that's driving our investments into those regions on how we deploy solutions.
Good, thank you. So we are almost in conclusion, Sid. My last questions, comments. So to close, what are some of the next smart home use cases and applications we can expect to become a reality in the next a few years, 2, 3, 4, with Edge AI?
Yeah, I think in summary, I would say this disruption is happening as we speak, right? And so we're talking quarters and maybe 1 to 2 years as opposed to too far down. But we see the smart home industry is going to get a major boost with this concept of Edge AI coming in, right? And it will, as a result, go through significant changes, mostly driven by specialized hardware that is also relatively small and relatively cost efficient. So the thing that we talked about, MCUs with neural processing units, etc. Right? We are convinced that Edge AI will be built on MCUs, and here with NPUs they have a lot of inference horsepower comparable to an NPU, but you don't need the power-hungry stuff of an NPU, right? So we see more and more of these high-end products being able to do stuff with lower-end MCUs. The integration of new sensors and efficient models, we are expecting a big surge in this, right? A lot more new sensors and also associated AI models that come together to create seamless and adaptive smart home, right? And experience it. So making, in the end, the homes feel more like a living companion that is intuitively doing things based on your patterns, right? And then, of course, in the end, the top priorities for smart home deployment are expected to be around security, including anomaly detection, privacy, followed by home, HVAC, smart thermostats, things like that. Those are kind of the more dominant basis of a smart home, and of course they go through the changes as well.
Good, thank you. So integration of new sensors, security, as you mentioned, these are very important features, as well as real-time anomaly detection. So Sid, any last words, key takeaway you would like our listeners to remember about the future of smart homes and Infineon's role in shaping this field?
Yeah, no, thanks, Maurizio. I would say in one sentence, I would summarize it as, look, the future of smart homes from our perspective is all around digitalization and decarbonization. And this is very much of what drives, when we look at product roadmaps and when we look at investments, this is what drives us. And I see a lot of traction here. So with that, thank you, Maurizio, and thank you to the audience.
Thank you, Sid. Thanks a lot, and have a good day. Stay in touch.
Thank you.
This episode of Embedded Edge was brought to you by Infineon. Thank you very much, Infineon, for sponsoring us. If you want to learn more about Infineon's solutions we have been talking about today, please check the links on the podcast page at eetimes.com or embedded.com or the Infineon homepage, infineon.com. Thank you.
That brings us to the end of this episode. Stay tuned for more news and technical aspects about embedded systems design. If you are listening to this on the podcast page at eetimes.com or embedded.com, links to articles on topics we have discussed are shown on this page. Embedded Edge is brought to you by Aspen Core Media. The host is Maurizio Di Paolo Emilio, and the producer is James Eade.